Good morning, everyone. I am Dr. Avishek Adhikary, and today I am here to present our poster presentation on the topic Type Identification of Packaged Fruit Juices using KNN on LDA-Reduced Hydrogel data. The authors of this work is Ragini Vinay Mehta, Shikha Kaiwart, Dibakar Rai, Khushi Dutta, Suchetan and myself, Avishek Adhikary. We are from the Electrical Engineering Department, Bioengineering Department, again Electrical Engineering Department, Electrical Engineering Department, and Chemistry Department and Electrical Engineering Department of the IIT Bhilai. Our discussion on the topic is comprised of the introduction and the objective of this work, the sensor description, the test protocol and data collection, and then there is going to be 3 case studies, final data analysis, results, and conclusions and references. So, why the type identification of the packaged fruit juices? Packaged fruit juices are increasingly popular as convenient alternative to fresh fruits. In India, brands such Real Fruit Juice holds a significant market share. However, it is very difficult nowadays to identify between the original packaged fruit juice and the counterfeit fruit juice. Now, it has been found that different brands and flavors have the characteristic sugar compositions which can be served as identifying biomarkers. However, if you cross-check whatever the nutrition information is given on the backside of the packaged fruit juice, they mostly include the total sugar counts. But we know sugars are different types. There are the hexose sugars, there is a double hexose sugars like fructose and glucose and sucrose, and there are a different percentage of these things, but these things is not easily available, and there are methodologies, different kind of chemical methodologies. Then there is a methodologies including near infrared sensors, surface plasmon resonance, and there is also different kind of plasmonic sensors which can find out the sugar profile of the different solution, but they are mostly lab based method, well equipped lab instruments, and the still personnel is required for that, and it is not possible for the commercial use or the common people use or the small market use. Motivated by this, we actually have this work. The whole idea is the basic motivation of this work to differentiate between the original fruit juice and the counterfeit fruit juice. But to understand or to reach up to that point, first we have to identify the different sugar profile of different brands and different flavors of the original fruit juice. This particular work focused on making a possible sensor which can identify the different brands, the sugar profile of different brands, and can classify the different brands and different flavors of the same brand. So the objective is to analyze the sugar profiles of the real fruit juice products and to establish baseline sugar profile signature for authentic real juices of different flavors for different brands. So in other way, we want to develop a system which has sample and sensor counted, and then it's put in the going to the signal to a measurement block, and then the classifier block, which will ultimately tell that what kind of sugar profile we are under trace, what is the flavor, what is the brand. So this is our sensor description. Our sensor description includes the branched polyethyl amine, which is PEI, and polyphenol alcohol. So in this study, a sugar-responsive hydrogel was synthesized by combining branched polyethyl amine and polyphenol alcohol and the cross-linker formyl phenyl boronic acid. During the fabrication, 40 milligram per ml PVA is stirred for 4 hours in 80 degrees centigrade, and 25 mg per ml PEI are mixed and allowed to cross-link in the room temperature for 2 to 5 minutes. The resulting hydrogel is formed the semi-transparent and with whitish irregular shape. This is the whitish irregular shape we can see in the figure, and then it is stored in the 4 degrees centigrade until further use. So this is the fabrication, which is simple, and in large scale we can actually fabricate within our lab environment also. However, the actual commercial level setup is not, fabrication is not yet set up. Now, the test setup. The test setup consists of a custom designed device. You can see this device here, custom designed device which has two steel electrode around face to face on fixed acrylic block. The device designed for two purposes. providing electrical impulse and receiving impedance response of the sensor, and transforming the irregular shaped gel to a fixed dimension cube. Impedance measurements are then conducted by the connecting crocodile clip of the Keysight E4980AL impedance analyzer with the electrode plates. Next, we have the data collection protocol. The basic test protocol comprises three steps: keeping the hydrogel in the sample solution for 2 minutes in fully submerged condition, taking out the sample soaked gel and placing on the device well, and collecting. The third step is the collecting the EIS data across the electrodes at 2 minute, 4 minute, and 6 minute instant after a gel placing on the device. In this work, juice samples of typical commercial packaged fruit brand real fruit juice is used. Total 240 samples belong to four different flavors: apple, guava, mosambi, and mango are used for this study with trained stress freeze 2:1. EIS is carried out on a frequency of 20 Hz to 200 kHz with 200 data points logarithmically equispaced. For each measurement, the entire EIS vector is denoted as, you can just consider that Z sample impedance, which consists of magnitude spectrum and phase spectrum, and real spectrum and the imaginary spectrum. So we have three case studies here under studies. Case one, the classification using the single feature full order impedance spectrum. Case two, the classification using PCA reduced imaginary spectrum. And case three, the classification using LDA reduced imaginary features. Classification learner toolbox of MATLAB 2024A is used, which comprises of 33 different machine learning architectures from different categories like support vector machine, K nearest neighbor, discriminant analysis, and others. And we actually train the system, train these classifiers with our trained data set, and we have actually find out the five-fold cross-validated accuracy so that the over estimation is not being done, and to find out which is the model is going to give us the best accuracy. So the case study one, we can see that we have actually deal with the four different impedance feature: the mod impedance, that is the absolute impedance magnitude, then the impedance phase, then the real impedance and imaginary impedance. In each cases, the ensemble superspace discriminant model is going to give us the best overall accuracy. The overall accuracy and the class-based accuracy, the apple, guava, mango, and mosambi, they are all shown here. And we can see the overall accuracy is found based in when we are choosing the feature imaginary impedance. Okay. However, still you can see that when we are using the full order impedance spectrum, that is 200 data point, we are actually getting maximum 75% overall accuracy, and the class specific accuracy also getting highest. That is also for the mango brand, that is also coming up to 85%, and we can also have the as poor as accuracy of the mosambi, which is only 65%. So we tried with the next case study, where instead of using the full spectrum, we are actually trying to find a dominant factor of this impedance feature, and we have used the PCS. So we have actually taken the first two PCS of the impedance feature, that is impedance, imaginary impedance feature. And in this case, we can have a clear visualization when we are actually using the 200 data points. We have a complex visualization and the multi-dimensional scenarios, but now we have a clear visualization in two-dimensional scenarios, and we can see how the data points are assigned. I mean, the represented within this PC1 versus PC2 two-dimensional space. However, we can actually see that even with this, the different kind of brands are completely superimposing each other, leading us towards the misclassifications. Okay. So that is why we can see that PCA is actually telling us that where is the problem is that we are having some misclassification due to the overlapping. So we actually tried with another mechanism, which is actually increasing the interclass separability and reducing the intraclass separability. So therefore, we are actually using the LDA, linear discriminant analysis, and with the linear discriminant analysis, we can actually see that three different with this at 3 different minutes of our sample. We have taken the sample 2 minutes after, 4 minutes after, 6 minutes after, how the data points are actually located in the LDA subspaces. So you can see that after 2 minutes, this interclass this distance is quite large. We are getting there, becoming closer when we are actually having the 4 minute and the 6 minutes. So we obviously has chosen from there the 2 minutes are the best suitable scenarios, and sorry, 4 minutes is the best suitable scenarios based on these observations. And finally, we have chosen the LDA with the two component is our data processing features from the raw EIS data. And when we are using this 4-minute data, we are actually applying it with the k nearest neighbor model. In the classification accuracy, the k nearest neighbor model is going to give us the best accuracy, and you can see the best the accuracy, the confusion matrix for the applying the k nearest neighbor model on the LDA reduced imaginary impedance feature using the 4 minutes data, and you can see the true positive rates for the mango and guava is above 95% for both training and testing. These are training confusion matrix, these are test confusion matrix. And for apple and mosambi classes, we have the classification performance with also the more than 90%. So this is a comparison with the previous work. In our cases, our overall accuracy is becoming 94.3%, which is much better than the earlier reported fractional capacitance-based method or chemical components-based method or a dielectric measurement-based method reported in different literature. So in the conclusion, we can conclude the imaginary impedance component feature is the most dominating feature to differentiate between the products of the same fruit brand. And with the 4-minute response time, the model can differentiate between 4 classes of the same brand real fruit juice up to 94.25% accuracy with the LDA reduced imaginary impedance input features of the KNN model. In the future work, currently we have also working on these things, and some papers has been reported that we are now extending this framework to now identify the adulterated fruit juice from this original fruit juice for all different brands. We're acknowledging the co-research grant sanction number CRG 2023007002 dated 7 February 2024, funded by the ANRF Government of India for supporting this project and carrying out the project work. These are our references in related to this work. And we thank you for all of you for giving us the time and this attention. Thank you.